See, this question is of a very standard category. The look of this expression is enough to give you a major hint. Is there anyone who's able to decode the hint? And it's a very easy question. This has a fixed template to solve. A very fixed template how to solve it, and it requires very basic understanding of differentiation. Very basic. Very, very basic. And questions like these have occurred in the past way too many times. Just the look of this expression is enough to remind you of the concept required to crush this question. Do you know anybody? Brainstorm, come on, think. Ponder upon it. Try to connect it with something that you already know. You have huge data of knowledge with you guys. You've studied way too much. You've eaten a lot of food. And I hope a big amount of it is digested as well. Yes? So from that chunk, you have to see what this expression is able to connect with. Anything popping up your head? Huh? See, write it down. Write it down. This is f of x minus f of y. And here you have less than equal to 2 times mod x minus y to the power 3 by 2. So it is 1 plus 1 by 2. So I've written it like this. 1 plus 1 by 2, broken it down the very first step. Now this mod x minus y, I will bring it on the left hand side and I will get f of x minus f of y upon x minus y less than equal to 2 times root over mod of x minus y. This is the time where you must realize that your left hand side actually resembles what? F of x minus f of c upon x minus c, as x tends to c is nothing but f dash c. How many of y'all have been able to recollect this very primary definition which you study as the first thing when you start with derivative? Yes or no? This is so important and such a minute piece of information, but such a bomb piece of information. If you know it, if you're able to recall it, you will be able to identify that at this stage, this is what I'm going to apply. Just in place of y, there is c, f of x minus f of c upon x minus c. So just apply limit x tends to y, and here also apply limit x tends to y. In place of y, there is c. That's it. That is it. In place of y, there is c. That is it. So limit x tends to y, your right hand side will eventually become 0. Right? But your left hand side will become what? Listen to me carefully. Mod function is a continuous function. Whenever you have a continuous function, limit and a continuous function can always interchange places. So limit and the mod function can interchange places. Limit is allowed to go inside mod because mod is a continuous function. Nobody will explain you with this much detail, but every ounce, every iota of the why ma'am did that should be clear in your head. Okay, so what am I going to get? Mod of, this is limit x tends to y, f of x minus f of y upon x minus y. Is this clear? Less than equal to 0. As I told you, this complete quantity is nothing but f dash y. Its mod is less than equal to 0. This is true for every y real. Connected? Got it this much? But mod of anything real is always non-negative. So if a mod quantity is sandwiched between 0, it is greater than 0 and also less than 0. It is greater than equal to 0 and less than equal to 0. That means it has no other option but to be simply equal to 0. Mod of something real is 0 if and only if that quantity itself is 0. So this implies f dash y is 0. Now y and x are just dummy variables. So basically what you are getting is f dash x is 0 for every x real. And what does this mean? If the derivative of a function is 0, that means the function itself is nothing but a constant. So f of x is coming out to be just a k. But it's given in the question that f of 0 is 1. So f of 0, which is k, is given to be 1. That means your function f of x is nothing but 1. It's a constant function 1. So if the question asks you 0 to 1 f square x dx, if f is 1, f square is also 1. 0 to 1, 1 dx, your answer is simply 1, bachche. This is how easy peasy lemon squeezy this question is. Easy peasy lemon squeezy question. Easy peasy lemon squeezy question. Is this clear? The only catch was, the only and only catch was this expression. This is a standard expression reminding you of the definition of f dash c. This. Okay, so the connect has to be established very strongly and very instantly, very quickly. That's when you will sail through the question and complete it within seconds. It's such an easy category question. Okay, I hope it's absolutely clear, guys. Hashtag HDCC in the chat. One more category, conquered, killed. So, kind of the questions which I'm sharing with you are itself representatives of categories. And that is why this is such a voluminous session, very rich quality session. Okay, come to this one. This question is very nice. Pretty nice question, guys. Take a look. Integral a to b x to the power 4 minus 2x square. If I is minimum, what is the ordered pair a comma b? Now see, when you say I is minimum, you have to realize what I gives you, any definite integral. What does it give you? It gives you algebraic sum of the areas of the region bounded by the curve and the x-axis. Yes or no? But algebraic sum, I've told you, algebraic sum. If the graph completely is lying above the x-axis, then integral gives you the area bounded by the curve and the x-axis. But if the graph has some portion up, some portion down, some portion above the x-axis, some portion below the x-axis, so all the above areas are going to have positive value, the below areas are going to have negative values. You will algebraically add it without computing the absolute value, and whatever that comes out as the answer is the value of integral. So I, the definite integral, can be positive or negative, but area can always be positive. I hope you remember I have taken a one shot on definite integral where you would know I have covered that how definite integral is different from area under curve. How definite integral is different from area under curve. Very loosely we do sometimes refer definite integral to be the area under curve, but it's not completely true. It's a very loose connection, and in a very specific scenario they both coincide. Otherwise, definite integral is the algebraic sum. So it can come out to be negative or positive. I am interested in the minimum value. Okay, let's start, guys. Let's start. What is my I? Integral a to b x to the power 4 minus 2x square dx. Now, obviously here the entire analysis is towards the integrand, which is f of x. So if I consider the integrand separately, it is this. So x square comes out common, you get x square minus 2, which gives you x plus root 2 and x minus root 2. Yes, equal to 0. This gives you what? X is 0, root 2 minus root 2. That means the graph of f is cutting, touching or intersecting the x-axis at these 3 points. 0, root 2 and minus root 2. The graph of f is cutting, touching or intersecting the x-axis at these 3 points, no other points. These are the zeros of f. Another very important fact, because it's a biquadratic polynomial. This is biquadratic polynomial, basically even degree. As x tends to infinity, f tends to infinity. As x tends to minus infinity, f tends to minus infinity. No, f tends to infinity. So no matter you go to extreme left of the x-axis or extreme right of the x-axis, the graph will always infinitely go up, 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 up. Okay, now let's compute f dash. So x to the power 4 means 4x cube minus 4x. This gives you 4x common, x square minus 1. So you are getting x as 0, 1 and minus 1. These are your critical points. So minus 1, 0, 1. Obviously plus, minus, plus, minus. Please check if there is any confusion. Yes. So minus to plus, this is point of minima. This is point of maxima. This is again point of minima. Are we in a position to now plot the graph? Let's see. Let's see if we can plot the graph, and let's see if we can somehow compute the algebraic area. Let's see if we can somehow compute the algebraic area, which is a minimum. Okay? Fine. So I know my function is having zeros as 0, root 2 and minus root 2. So let's say this is minus root 2. Let's say this is root 2. Let's say this is 1, this is 0 and this is minus 1. One very important thing to observe is minus 1 is the point of minima for sure. 0 is the point of maxima, but at 0 function's value is also 0. At 0 function's value is 0, but 0 is also the point of maxima. So how will the graph behave? How will the graph behave? Obviously, the graph is going to come down passing through minus root 2. At minus 1, attain its minima, go. Attain its maxima at 0 again, minima at 1 and then go and pass through root 2. That's it. That is it. Yes or no? Because at f of 1 and f of minus 1, the value is going to be same. Yes, 1 minus 2, which is minus 1. So f of 1 is minus 1, f of minus 1 is also minus 1. So this peak, as you can see, is at minus 1. Are you understanding? Are you understanding? Is this graph clear? So as you are approaching to minus infinity or infinity, the graph is going infinitely up. At 0, it is attaining maximum, but at 0, it is also touching the x-axis because f of 0 is 0. At minus root 2 and root 2, it's also the same. The graph is passing through the x-axis. At minus 1 and 1, it has point of minima. Is this clear? Now, if I want the minimum value, integral a to b of this function, when will you get minimum value? Minimum value for a definite integral means as negative as possible, right? Because definite integral's answer can come out to be positive or negative. It's not talking about area, it's talking about definite integral. So for definite integral to be its minimum, I want it to be as negative as possible. So as negative as possible, this is going to have negative value when you solve because it's below the x-axis. This will have negative value when you solve, right? So the sum of these two will give you the minimum, most minimum value of I. So I will have to calculate from minus root 2 to root 2 of f of x dx. This will give you the minimum value of I, which is going to be the most negative. And that is why integral a to b should be integral minus root 2 to root 2. Option C. Is this clear? So this question again involved more of differential calculus somehow, but you know how it involved integration as well. Because it actually involved the very basic, fundamental, very starting point of definite integral, that what is the geometric interpretation of definite integral and how is it different from area under curve. If you are someone who has forgotten it, please go. The first 10-12 minutes, I have just explained this much. Even if you want to watch just this much, go and visit the video. Everything will be crystal clear to you. What is definite integral's definition? What is its geometric interpretation? How is it different from area? Is it cool? Yes, everyone? So C here is the right answer. Let's go to the next one. This is a beautiful question and trust me, it's very easy. Why, ma'am? How, ma'am? Allow me time. The moment you see GIF, something inside your brain goes in a panic situation. Yes or no? Yes, ma'am? No, ma'am? The moment you see GIF, something inside your brain goes in a panic situation. Okay. But here, things are going to be very simple. Why, ma'am? How, ma'am? Look, do not solve the integral. Please learn the smart approach. Because GIF is involved, you know that in different intervals, GIF comes out to be different. After every 1 unit interval, the value of GIF changes if I talk about the function GIF of x. So somehow, the value of GIF of x by pi will also be different. It won't be the same throughout the interval minus 2 to 2. So what I need you to do is, I need you to break this down. Minus 2 to 0 plus 0 to 2. This much is sine square x. What is GIF of x by pi? See, if you are saying that my x is lying between minus 2 and 0, x by pi is actually lying between minus 2 by pi to 0. Tell me. Huh? And minus 2 by pi, minus 2 upon 3.14, it is a negative fraction. This is greater than minus 1. Yes or no? That means x by pi actually is sandwiched in this 1 unit interval. Yes, minus 1 to 0. So its GIF is going to be minus 1. So here I get minus 1 plus half dx. Can you see this? Next, here again there is a sine square x. Again, if your x is sandwiched between 0 and 2, x by pi will be sandwiched between 0 and 2 by pi. 2 by pi is a positive fraction which is less than 1. That means x by pi is lying in 0, 1 interval. That means GIF of x by pi obviously will be 0, and that is why we have broken this integral down into sum of two integrals, minus 2 to 0 and 0 to 2. Okay, because you can see in minus 2 to 0 the value of GIF is 1, in 0 to 2 the value of GIF is 0. So here you get 0 plus half dx. Okay, that means eventually you are getting minus 2 to 0 sine square x dx, and here I have minus 1 plus half means minus half. Okay, plus again sine square x dx, this is 0 to 2, and next is upon half. This is upon minus half, so this is minus 2 upon half, so this is 2. What to do next? Somehow you can see the integrand is matching. This is sine square x, this is sine square x. Can you club them? Can you somehow convert one into another? Can you somehow solve this expression without actually computing the integral? Without actually computing the integral, can you solve? Tell me. Any substitution? I guess some people are guessing it right. In the first one, replace x with minus x. So dx will be replaced with minus dx. So what will this get converted to? When x is minus 2, replace it with minus x. This will become 2, this will become 0. Sine square of minus x is sine square x only. And dx will be replaced with minus dx. Okay, fine, not a problem. This minus and this minus vanishes, and this is what you have. 2 times 0 to 2 sine square x dx. This part is as it is. And you can see 0 to 2, 2 to 0. What will you write this? Minus of 0 to 2? Minus of 0 to 2, which means they both cancel out. Your answer is a big fat 0. Basically, the situation was integral a to b plus integral b to a of the same integrand. The answer is 0. Because of the interchange of limit property. Remember, integral a to b is nothing but minus of integral b to a. And that is why eventually they both cancel out to give you 0 as the answer. So in questions like these, guys, don't panic. Don't let the question press your panic button, your anxiety button, your stress button. Do not give the question that power. You are controlling the question. So always remember that you have learned, now it is in your system, in your memory, in your body and in your mind, that whenever you get questions like these where you have GIF involved, learn to break the integral into 2 and try that you don't have to in the first go solve it. Somehow if they both can be connected in a way, one can be converted to another and you can resolve it, simplify it as much as possible, please proceed in that direction. Okay, don't immediately jump into conventionally starting to solve the integral. It is very time consuming and it is unnecessary time waste. Okay, all right. Is this clear? So 0 is the final answer. Option B. Let's come to this one. Now, I really like this question a lot. And I want you all to please consider this question to be one of the nicest questions of today's lecture, because this involves a beautiful concept which scares a lot of students, and that is none other than ITF. ITF. How will you solve this? It says value of this integral is what? Just look at the integrand. It says x times cot inverse of this entire expression. One thing is absolutely clear. If you carefully observe, one thing is clear. This x is pakka positive. X is lying between 0 and 1. So x is a fraction. X is definitely a fraction and hence it's positive. If x is a fraction, x square is also a fraction. So 1 minus x square is definitely positive. And x to the power 4 again is positive. That means this completely is again positive. So what I have is a positive quantity into cot inverse of something positive. Is this again ringing some bells? Ringing some bells? Yes or no? Jingle bells, jingle bells. Is this ringing some bells? Cot inverse of something positive. What is this equal to? Do you remember? Cot inverse x is equal to tan inverse 1 by x when x is positive. And it is pi plus tan inverse 1 by x when x is negative. How many of you all know this result? It's a very, very cute little question, you know. It's not a very heavy, very challenging question, no. It's a very easy breezy question. This is something which you must know, everyone. Some of the results of ITF are absolutely non-negotiable for you to learn and master. Please remember this one. Here in my situation, I have cot inverse of something positive, right? We analyzed. So my integral will turn into what? Integral 0 to 1 x as it is. Cot inverse of something positive is tan inverse of 1 upon 1 minus x square plus x to the power 4 dx. Now what? Now starts manipulation. The denominator 1 minus x square common 1 minus x square. Yes or no? Or you can write it as 1 minus x square into x square minus 1 with a minus sign outside. Now what does this look like? 1 plus ab. Tan inverse of a minus b upon 1 plus ab is tan inverse a minus tan inverse b. Somehow this is reminding us of converting this into tan inverse of a minus b upon 1 plus ab. How will you convert it into a minus b? Huh? Isn't this 1 equal to x square minus 1? Huh? Yes or no? Tell me, it's not something which is rocket science. It's very simple. Come on, the expression itself is giving you such familiar expressions that you can deal with this and you can change the argument of tan inverse into a minus b upon 1 plus ab. This becomes integral 0 to 1 x times tan inverse of a minus b. So x square minus 1 minus x square. A minus b, x square minus 1. So sorry, this is x square minus 1. A minus b upon 1 plus a into b. And this is dx. So you are getting x into tan inverse of x square minus x into tan inverse of x square minus 1. 0 to 1, 0 to 1. Tell me if there is any doubt, any confusion till here. So this much part I've understood was tan inverse of a minus b upon 1 plus ab, which is tan inverse a minus tan inverse b, which is tan inverse a minus tan inverse b. Tan inverse a minus tan inverse b. So I have distributed it in terms of two integrals. Now tell me, what will you do? Think. Come on, think. Tell me. I'll write it here. You have 0 to 1 x into tan of x square, tan inverse, right? Tan inverse, na? Tan inverse of x square dx minus integral 0 to 1 x into tan inverse of x square minus 1 dx. Now the first thing which should strike you is, let me take x square as t so that 2x dx is equal to dt, because we already have x dx sitting, right? So this will become what? X dx will be dt by 2. And this is tan inverse t. What about the limits? When x is 0, this is 0. When x is 1, t is also 1. Now here again, what you do is you take x square minus 1 as t, correct? So 2x dx again, this is dt. So this will come out to be what? X dx is dt by 2. And this is tan inverse again t. What about the limits? When x is 0, this is minus 1. When x is 1, this is 0. Oh, the problem is the limits. If limits would have matched, I would have got the same expression, ditto photocopy. Yes, If suppose, let's say, students have done this mistake, you don't focus on changing the limits and in a hurry, you write 0 to 1, immediately you will cancel both these out, you will get a 0 and that will give you marks also as 0, not even 0, -1. So don't be in a hurry. It very much looks like inviting, it's very attracting. This is inviting us to actually cancel the both integrals and feel that dopamine rush and write a 0 as the answer. But this is a trap, people. This is a trap. The moment you are sincere in converting your limits also, this will be -1, this is 0. You will realize I can't cancel this and the answer is not 0. So what I will have to do is, here I will replace t with -t, dt with -dt. And hence this complete integral will convert into what? I will get 1/2 integral tan inverse of -t is minus tan inverse t, because this is an odd function. Dt is minus dt. Okay, and this is 1 and this is 0. Yes, minus cancels out. So what you are left with is half times integral 0 to 1 tan inverse t dt. This is a minus sign integral 1 to 0 tan inverse t dt. But I don't want a minus sign, rather I can use the minus sign to convert the limits. This is 0 to 1 and there is a half as well. So half times this plus half times same integral is nothing but 1 times 0 to 1 tan inverse t dt. That is it. That is it. This is the integral you have to solve. 0 to 1 tan inverse t dt. That is it. 0 to 1 tan inverse t dt. What do? Isolate first function, second function. So you get first function, integration of second minus differentiation of first into integration of second dt from 0 to 1. So this gives you tan inverse 1, which is pi/4. Next is 0 only. And this is what? T upon 1 plus t square. So 1 plus t square if you take as u, 2t dt will give you du. So t dt will give you du by 2. T dt will give you du by 2. And this is 1 upon u. What are the limits? When t is 0, this is 1. And when this is 1, this is 2. Integration 1 by u is log u. So 1 by pi/4 minus 1 by 2 log u from 1 to 2. This will give me just log 2. So pi/4 minus 1 by 2 log 2. Please check this quickly. Please check this quickly. Pi/4 minus 1 by 2 log 2. Is that what you are getting as the answer? Let's check if it is there in the options. Pi/4 minus 1 by 2 log 2. Absolutely correct. Everyone tell me right now, is this question bang on crystal clear? Yes or no? This question itself again tried to give us a hint of cot inverse of something positive, which should remind you of this result. Very powerful result, something which is underestimated by students a lot. They take this result for granted and this is where it pops up and takes marks from you, away from you. Okay, after this, a very important aspect is converting this in the form of tan inverse of a minus b upon 1 plus ab. Very, very important category of questions which involve such a manipulation, and this manipulation is very rewarding. So you must understand how and when do we manipulate. After this, it was just substitution and we got our answer. Correct? Correct? We simplified the entire integral into just this much, and after that, applying bypaths, it was a cakewalk. Hashtag HDCC everybody. If there is any doubt, any confusion, let me know right now straight away and put it down in the comments, because this was a question involving inverse trigonometric functions. I know some of the concepts might not be that clear because it is a chapter which kind of is weak for many students. This is a chapter which a lot of students actually ignore and they leave. But there are certain results, bache, which are absolutely non-negotiable for you to learn and master. So even the results which are coming along the session as we are solving the questions, if some results of inverse trigonometry comes into picture, write it down inside the dabba, because the moment you write it down, there is active recall which is happening. You are applying it in the question as well. So application is happening, and because you are writing it down, you're not just remembering, you're writing it down. So there is a muscle-mind connection happening. So the chances of you being able to forget that result are next to impossible. Okay, now come to this question. is first of all a very beautiful question and a non-standard question from area under curve. It will look like question on area under curve, but actually it is not. And that is why it's a beautiful, pretty different question from area under curves. Let's see, a curve passes through the point 3, 3. Area of the region under this curve above the x-axis and between the abscissas 3 and x, which is greater than 3, be y cube by x cube. This statement is where I want to stop. Area of the region. Guys, please take a moment to appreciate the language. Area of the region under this curve above the x-axis between 3 and x is given to you. What does this mean? Area under the region, area of the region under the function above the x-axis. That means the graph is drawn in the first quadrant. Let's say it's drawn in the first quadrant. Of course, between 3 and x. So the graph is drawn in the first quadrant. You are taking area under the curve above the x-axis from 3 to x. How will you write it down in the language of mathematics? In the language of mathematics, how will you write it down? Huh? Any idea? In the language of mathematics, how will you write this down? This is nothing but integral 3 to x f of x dx only, na? Because your y equal to yx function or y equal to f of x function means the same. So this is what is given to you to be equal to what? Y cube by x cube. That means f of x whole cube by x cube. Superstar step, everyone. Such a big statement got compressed to this integral. You know, it's like this is 3 and say this is x and this is somehow the curve. So what are you doing? What are you doing? This is what you're doing. This is the area you're talking about. See this? This is the area you're talking about. This curvy figure is your actual graph of f. So area below the graph of f above x-axis, which is bounded between these two vertical lines, x equals 3 and also x. 3 and x, where x is greater than 3. This region's area is represented by this integral 3 to x f of x dx, which is given to you as f of x whole cube upon x cube. Okay? Is this cool? This is very, 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 very important. Yes or no? If this curve also passes through this point in the first quadrant, what is alpha equal to? But this kind of is acting like a initial value condition that the curve passes through a point. So initial value condition, let's come to it later. Right now what I have is integral 3 to x f of x dx is equal to what? F of x whole cube upon x cube. Let me take x cube to the left hand side. Now I will do what? Tell me. 100% correct. So many of you all have guessed. Of course, I am now going to differentiate both sides. I will differentiate both sides. What will I get? I will get first function. Differentiation of second will require me to apply the Newton-Leibniz rule. I will get f of x. First function differentiation of second plus second, which is 3 to x f of x dx. First differentiation of second plus second differentiation of first equal to 3 times f of x whole square into f dash x. Now the problem with integral of f is that this is equal to f cube upon x cube. Plug it back. You have x cube into f plus f cube upon x cube into 3x square is equal to 3 times f square into f dash. So this x square vanishes. Vanishes or not? Huh? So what do you get? X to the power 4f plus f cube 3 times equal to 3x f square f dash. See, it might look a little dense to you, a little complicated to you, but actually it's not. Actually it's not, because now you will convert f in terms of y. You will write x to the power 4 because that is how we are familiar in identifying an expression, plus 3y cube Okay, plus 3y cube equal to 3x y square y dash is equals to 3x y square dy by dx. Absolutely correct. Absolutely correct. Yes, ma'am, no, ma'am. Now, throughout I can see there is a y which can come out common and can get cancelled. Okay, so I will get x to the power 4 plus 3y square equal to 3xy dy by dx. Can you simplify this? Come on, come on, come on. Can you simplify this? Huh? Tell me, no? Is this kind of fitting into the linear differential equation category or homogeneous category? No. Variable separable? No. What to do? This is, Bacha Party, convertible to linear differential. This is actually Bernoulli's differential equation. Why? Because if you plug in y square as t, you will get 2y dy by dx is equal to dt by dx. Is this making sense? 2y dy by dx is dt by dx. So you have x to the power 4 plus 3t equal to 3x y dy by dx is 1 by 2 dt by dx. So you are basically getting dt by dx, there is a 3x by 2 here, is equal to 3t plus x to the power 4. So multiplied by 2 by 3x, multiply by 2 by 3x quickly. Multiply by 2 by 3x. Here also multiply by 2 by 3x. What do you get? Coefficient of dt by dx is 1. 3 cancels out. You get 2 by x into t plus 1x cancels out. You get 2x cube by 3. Basically, this is dt by dx plus minus 2 by x times t is equal to 2x cube by 3. Now it's a perfect linear differential equation. Please check this out. Yes? So I had a Bernoulli's equation. Bernoulli's equation simply means it's convertible to linear differential. Very successfully, I have converted this to linear differential. Now, what is the integrating factor? E to the power integration of minus 2 by x dx. This is log x, which is 1 by x square. X is greater than 3, no? So x is positive. Because x is positive, I can get rid of the mod sign. There is absolutely no need. And hence, I get mod x to the power 2, which mod x to the power minus 2, which means 1 upon mod x whole square. But x is positive, so 1 upon x square. So 1 upon x square. Is this cool? Is this cool? So t into integrating factor is integration of q. Q is what? 2x cube by 3. Into integrating factor dx plus c. Yes, so x square, this cancels out. So 2 by 3 integration x dx. So you are getting 2 by 3 into x square by 2 plus c. This cancels out. You have x square by 3 plus c. This is 1 by x square. And t was nothing but y square. So y square by x square. This kind of looks like your curve, but still c is unknown. Still, bachche, c is unknown. How do you plan to find it? Still, your c is unknown. Na? How do you plan to find it? So first of all, because your curve is passing through 3, 3, this is the very first initial value condition given, no? So you will get 9 by 9 is equal to 9 by 3 plus c. This is 1 and this is 3. So c comes out to be 1 minus 3, which is minus 2. That means your curve is y square by x square equal to x square by 3 minus 2. This is your curve. Now that you have your final curve with you, this is like this has no more unknowns involved. Now, what can I do? See, this is y square equal to x to the power 4 by 3 minus 2x square. Let's say this is the final curve. Now, it also passes through alpha comma 6 root 10. alpha comma 6 root 10. So you have 6 root 10 whole square equal to alpha to the power 4 by 3 minus 2 alpha square. This is 36 into 10 means 360. So 360 is equals to alpha to the power 4 minus 6 alpha square whole upon 3. 1080. 1080 is equals to alpha to the power 4 minus 6 alpha square, or rather alpha to the power 4 minus 6 alpha square minus 1080 is 0. Yes? Now because I have alpha square, I want a quadratic in alpha. Basically, I will take alpha square, let's say as t, which obviously will be positive, and I will get t square minus 60 minus 1080. So t will come out to be minus b plus minus root over b square minus 4ac will give you 66 upon 2. When you will compute the answers, you will get one positive answer and one negative answer. T is what? Alpha square, it can never be negative, so you will accept the positive answer. Can you see the calculation? It's very simple. The moment I have got my curve, so it's like this. The moment I've got my curve, now I'm doing what? I'm substituting in place of x alpha, in place of y 6 root 10. That's it. It's giving me a biquadratic in alpha. I'm deliberately, to simplify it, plugging in alpha square as t, which is converting it to quadratic in alpha. I'm solving it. I'm getting two answers. One is 36, one is something negative. You can calculate. T is alpha square, it cannot be negative. So positive answer is accepted. Alpha square will be 36. That means alpha will be plus minus 6. But the question already said that alpha is positive because this point is sitting in the first quadrant. So alpha has no choice but to be positive, and that is why alpha is not equal to minus 6. Alpha is equal to 6. 6 is the right answer. Did you understand? So right in the beginning, the question talked about area under curve. Yes, how it is converted in terms of mathematics language, in terms of definite integral. After that, we differentiated, converted it to a differential equation. But that was not a very straightforward differential equation falling in the category of homogeneous or variable separable or linear differential. It was convertible, and that was the catch of the question. We had to substitute, and then it was very easily convertible to linear differential. After that, we have just used the initial value condition to solve it and compute the actual curve. That means solve for y without involving some expression I want between y and x, which doesn't involve any unknowns, any variables, whose value is still not determined. The moment I reach that stage, I call it my final curve, and then because alpha comma 6 root 10 is lying on the curve, perfect. I plug in, solve, get alpha. Is that clear? Is that clear, everybody? Any confusion, any doubt till here? The question statement was pretty long, I completely agree, but the question was pretty fab, yaar. I will say this is a very nice question, and you must attack this question, solve this question, brainstorm upon this question, and also sit with this question to let it internalize in your system. Okay? Hashtag HTCC, everybody. Quickly in the chat, flood the chat with hashtag HTCC, and we come here. What is this? The first question that we did today, somehow this is resembling that itself. Yes or no? Limit of a sum, everybody. Limit of a sum. Yes or no? Yes or no? Is it difficult? R upon 2r square minus 7rn plus 6n square. If I take out n square common, you are left with 2 times r by n whole square minus 7 times r by n plus 6. This n square which has come out common can be written in two forms. One is like this and one is like this. So n square is 1 upon n square is what? 1 upon n into 1 upon n. So 1 upon n goes here and another 1 upon n comes here. And bingo. Bingo, I have summation here and I have summation here. R is running from 1 to n. You know, as a matter of fact, the moment I have summation of a function of r by n, into 1 by n, where r is going from 1 to n, let's say, this is straight away convertible to limit of a sum in terms of definite integral. What will be this? Integral r by n goes to x. R by n converts to x. This is 2x square minus 7x plus 6. This is tx, and obviously this is 0 to 1. In the first question, I've explained this to you in detail, so I hope you know this, and I hope there is absolutely no confusion. Correct? Please factorize this. 2x square minus 4x minus 3x plus 6. So 2x, x minus 2 minus 3, x minus 2. 2x minus 3 into x minus 2. Okay? So you are getting integral 0 to 1 x upon 2x minus 3 into x minus 2 dx. Now, here at this stage, please realize that we have to use the concept of partial fraction. Yes or no? Yes or no? And for that, what do? Don't forget, we will apply shortcut. Don't forget, we will apply shortcut. So x upon 2x minus 3, a linear factor, into a distinct linear factor, which is x minus 2. This is a upon 2x minus 3 plus b upon x minus 2. You know the shortcut? Do you know the shortcut? Yes or no? Do you know the shortcut or not? So this is x minus 2, one of the factors. When you equate with 0, you get a critical point 2, x equals 2. Now you know at x equals 2, x minus 2 will vanish. So on the left hand side, apart from x minus 2, you select everything and you put x equal to 2. You will get 2 upon 4 minus 3, which is 2 upon 1, which is 2. That means the value of b is nothing but 2. That's the short trick. Similarly, another factor is 2x minus 3. Its critical point is 3 by 2. At 3 by 2, 2x minus 3 is 0. So leave 2x minus 3 and select everything else on the left hand side. Plug in x as 3 by 2 upon 3 by 2 minus 2, which gives you 3 by 2 minus 1 by 2, which gives you minus 3. So the value of a is minus 3. Is this clear? Is this clear? So integration becomes what? Integral from 0 to 1, a is minus 3 upon 2x minus 3 dx plus 2 integral 0 to 1, 1 upon x minus 2 dx. Yes? And now it's very simple. This is to chalo partial fractions. Alright, what next? Minus 3 as it is. Log of 2x minus 3 upon 2 integral from 0 to 1 plus 2 times log of x minus 2 integral from 0 to 1. Limits from 0 to 1. So log of minus 1, that means log 1. Okay, log 1 is 0 minus log of 3. Fine. So this is minus log 3, or minus minus becomes plus. This is log 3 plus this is 2 times log of what? 1 minus log 2. So log 1 is 0. You get 2 into minus log 2. Yes or no? Yes or no? 2 into log 2 is what? 2 into minus log 2. This is what you get. Or minus of 2 log 2. Tell me. So this becomes what? Log of 3 to the power 3 by 2 minus log 4. 3 to the power 3 by 2 is what? Tell me. This is like 3 cube and square root. Isn't it? This is like square root of 3 cube. 3 cube is 27. 27 square root gives you 3 root 3. So this gives you log m minus log n, which is log of m by n. That's it. This is your answer. Log m minus log n is log of m by n. Is this clear? A very easy, simple, dimple limit of a sum question. Is this clear? Absolutely clear, guys, because now I am about to attack the last question of today's discussion. The last question, and a bomb question. This is from JEE Advanced. Multi-conceptual, very enriching, very nice question. F is a non-constant, twice differentiable function defined on the entire real line. such that f of x is f of 1 minus x. This is a functional equation. This is a functional equation given to you and it says f dash of 1 by 4 is 0. All right. Now this is not f double dash, this is f dash. Option A says f dash vanishes at least twice in this interval. I am only interested in 0 to 1. F dash half is 0. Integral from minus half to half, f of x plus half into sin x is 0. And what about option D? Always remember, whenever you are given a functional equation and the question talks about derivative, straight away differentiate. You have f of x equal to f of 1 minus x, and this is true for every x real. Correct? So when you differentiate, you get f dash x equals to minus of f dash 1 minus x. Always do that. Next thing which you always must do is, for what value of x is x equal to 1 minus x? X equal to 1 minus x means 2x equals 1 or x equals half. That means when you plug in x as half, you will get f dash half here and again minus of f dash half here. So twice of f dash half will give you 0 or f dash half is 0, people. Now please understand, the question talked about this interval 0 to 1 and the option said f dash half is 0, which is true. F dash vanishes at least twice. At half though it vanishes. At half though it vanishes. At 1 by 4 also it vanishes. No. It's given in the question at 1 by 4 though it pakka vanishes, f dash. And I have found out using this very promising and a very standard method that at half also f dash vanishes. So definitely it might vanish at more points, but at least 2 times it is 100% vanishing. At 1 by 4 and at 1 by 2, so it's pakka vanishing. It might vanish at more points also. That I don't care. Looking at the option, it is 100% true that f dash is vanishing at least twice in 0, 1. Okay. Let's come to C option. Look, it says integral minus half to half is 0. Minus half to half reminds you of minus a to a. Integral is 0 when your integrand is an odd function. If somehow this complete integrand, let me call it g of x, if this comes out to be odd, my option C will also be correct. Integral minus a to a odd function is 0. So is this an odd function? Let's check. G of minus x should come out to be equal to minus of g of x. Then g will be odd. So g of minus x will give you f of minus x plus half into sine of minus x, which is minus sine x. So you have minus sine x as it is. What is f of minus x plus half? What is f of minus x plus half? You are given f of x is equals to f of 1 minus x. And this is true for every x real. If x is real, arey baba, x plus half is also real. Now what's the problem? So you can manipulate your functional equation to get what you actually desire because it is true for every x. It's a generic equation and you can keep on plugging in different values of x or expressions of x because it will continue holding true. Like now I will replace x with x plus half. So you get f of x plus half is equals to f of 1 minus x minus half. So this is f of minus x plus half. That means f of minus x plus half is equal to f of x plus half. F of minus x plus half is equal to f of x plus half. Now, bache. And what is this? This is minus of g of x. So, this implies g is an odd function. The moment g is odd, definitely its integral from minus a to a will come out to be 0. No doubts about it. A, B, C all are correct. What about option D? What about option D? Option D is also very simple. It is asking us to equate these two integrals. So it's very easy. This is your, let's say, left hand side integral. This is your, let's say, right hand side integral. In your right hand side integral, if you take 1 minus t as u, minus dt will come out to be du. So your integral will turn to what? Tell me. F of u e to the power sine pi t. T is what? T is what? 1 plus u. So pi plus pi u, right? This is pi plus pi u. Please check this. Sine pi t. Oh, t is 1 minus u. So sorry, 1 minus u. So pi minus pi u. And then you have dt, which is minus du. So dt, which is minus du, when you plug in t as half, 1 minus half gives you half, and 1 minus 1 gives you 0. Now, can you see this? Understood? I've just picked up the right hand side integral and substituted 1 minus t as u. This is what I'm getting. Now, sine of pi minus theta is sine theta. So this is same as sine pi u. Correct? And because of this minus sign, my limits are going to interchange and I will get integral 0 to half f of u e to the power sine u du. If you treat u and t as dummy variables and same, your left hand side is also the same, 0 to half f of t to the power sine pi t dt, and right hand side has come out to be 0 to half f of u e to the power sine u du, exactly the same, LHS equal to RHS. So you started with RHS and you've manipulated it by the perfect substitution and converted it equal to LHS. Bingo, you're done. Easy peasy lemon squeezy. So advanced level question, but a very beautiful category. Always remember this method is without fail kick-ass method to give you beautiful conclusions. Always when you are given a functional equation, question talks about differentiation, differentiate it, and then try to find out that x for which both of them are equal. That means x is equal to 1 minus x, which is x equal to half obviously. So you will reach a very important conclusion. Okay, this will really help you in answering other questions as well. Cool. So this process is something you have to absorb nicely. Correct? And functional equations power is something which you should never underestimate, guys. You are given f of x equals f of 1 minus x. This is not true just as it is. You can replace x with similar expressions or multiple different expressions. Replace x with multiple different expressions as and when the need arises. The functional equation continues to hold true. That's its power. That's its power. Okay? Cool? Alrighty, folks. So for this question, all the 4 options are correct. And on this note, this is your homework question. You have to put your answer in the comment section below. And if you've not yet joined the Telegram group, please do that. It's Study with Bhoomika Ma'am. Okay, this is the Telegram channel. This is the address, Study with Bhoomika Ma'am. Definitely join the channel. You can interact with me on a personal level, academic level. I would love to cater to your doubts, all your queries, your concerns, any confusions you're facing, any anxiety you're facing, any doubt you're facing. That is the platform where I'm actively available for my students, for my hustlers. Okay, so on this note, it's me, Bhoomika, signing off, guys. I know a lot of questions have been done today and a lot of questions will they're still pending to complete that 100 mark barrier, and for that I will be sharing again a PDF with you like I did last time also. After my first PYQ marathon, I have shared a good 70-75 questions PDF on the Telegram channel, okay, which completes the bunch of full 100 questions, which has been done corresponding to the first PYQ marathon. For this PYQ marathon on integral calculus was special. Your differential calculus has been done, yes, and you're on the neutral calculus series, again selecting beautiful questions for your practice, creating a PDF and sending that to you on Telegram, and hence our 100 question mark is going to be completed. All right, okay, I hope you enjoyed today's session. If you did, drop down in the comments some love, and do not forget to share the session with as many folks as you can, because sharing is ultimately caring. So please be kind. Don't forget that if someone needs help and you have the capability to help that person, you must extend that help, because it always comes back to you. All right. On this note, on a very positive note, and lots of love from my side to you, a very happy new year once again. And it's me, Bhoomika, signing off.